So we begin the next lecture of our Forensicotomy series, and this last lecture, as the title displays, it deals with the appearance of the body after death. So after hearing the title, I'm sure the first thing that is coming in your mind is about decomposition. Decomposition is a complex process. Normally, what we normally, in terms of layman, what we think of decomposition is skeletalization, i.e., only the bone remaining of the whole body. That's what we think of decomposition. But in the medical science, things are never so simple, and everything is a complex, goes through a complex series of events to give the final outcome. So, decomposition, we are talking about the decomposition, and this lecture deals with the decomposition. Decomposition has two broad categories: rapid decomposition and delayed decomposition. In this lecture, we are only going to study the delayed decomposition, and in the next lecture, i.e., the appearance of the body after death, part 2, we will study the delayed decomposition. The rapid decomposition has further two types. The first one is minor rapid changes of decomposition, and the second one is, can you guess it for me? What's the antonym of minor? Yes, you're right, major rapid changes. So that's the summary of what we are going to study in this lecture. The decomposition has two broad categories: rapid decomposition and delayed decomposition. Delayed we are going to discuss in the next lecture, and the rapid has two types: minor rapid changes and major rapid changes. So let's go to the next slide and read the text together. Rapid changes after death. Rapid changes after death. The first bullet point tells you that there are 4 minor rapid changes, and the next bullet point tells you that there are 4 major rapid changes. And another thing that you should know is that the minor rapid changes are not that high yield, and a little bit beyond the scope of the purpose of this lecture series, as I previously mentioned that in this lecture series, i.e. Forensicotomy, is to make the students aware of the high yield topics that have previously appeared in the KMU past papers. Minor changes are not that high yield, but why should we bother going through them? Is because in order to build a good understanding, a strong foundation for understanding the major rapid changes, we need to understand the 4 minor rapid changes. And the 4 minor rapid changes, the first one of it is the retinal vessels. The retinal vessels viewed with an ophthalmoscope show the breakup or fragmentation of columns of blood. This is called trucking. So the first change is the trucking event. The second is the whole body muscular flaccidity, and the third change is pallor. The fourth change is the loss of integrity of the sphincter stone. So there are 4 minor rapid changes. We need not to go much in detail. The first one is trucking of the retinal vessels, i.e. the fragmentation of columns of blood. If we view the retina of the cadaver, rather I should say a fresh cadaver, the ophthalmoscope view of his or her retina will show the fragmentation of columns of blood, and this is called the trucking of retinal vessels. The next is the muscular flaccidity, third is pallor, and the fourth is loss of tone of sphincters. So let's go to the next slide and read the text together. 4 minor rapid changes, the same stuff: trucking of retinal vessels. Retinal vessels used in an ophthalmoscope show breakup or fragmentation of the columns of blood, which is referred to as trucking or shunting. Now, why is this name given? That's a task for you. It's not that high yield, but I think you should know. It will help you remember the name and the event. The second is muscular flaccidity and twitching. It is important to note that this flaccidity is called primary flaccidity. So if there is a primary flaccidity, what you get from it, or what you should take home from it, is there should be a secondary flaccidity too. So what's the secondary flaccidity and what's the primary flaccidity? Primary flaccidity is one of the rapid changes. Secondary flaccidity is one of the delayed changes, I should say. And between them there is another event of stiffness, whole body stiffness, which is called, what do you call stiffness in forensic? So in the sophisticated language of forensic, yes, you are right, the rigor mortis. So prior to the rigor mortis, there is complete flaccidity, which is called primary flaccidity, and after the rigor mortis, there is again complete flaccidity, which is called secondary flaccidity, and there is also twitching. Now, why does twitching occurs? Twitching is seen because of the discharges of the doing motor neurons, which may stimulate small group of muscle cells, and this leads to the focal twitching. There is generalized pallor, and why generalized pallor? Generalized pallor is due to GI problems, right? Pallor is seen due to GI problems. I'm just kidding. Yes, you're right. It's due to CVS issue. And why CVS issue? Because there is cessation of circulation. So there will obviously be generalized pallor. And the sphincter tone and the integrity of the sphincters is compromised. Why it's important to know is, can you guess the three major types of sphincters that are found in a human body? Start from head to down. Here is a human body. I'm very good at drawing actually, so you need to appreciate that fact. The first one, going from top to bottom, the first sphincter is, yes, you're right, the lower esophageal sphincter. The next one is the urinary sphincter, and the third one is the rectal sphincter. So why is this point so important? Why did we bother mention it again, since once we have already mentioned that there is whole body muscular flaccidity? Why was it important to again mention that the sphincter tone will be lost? It is because of the loss of sphincter tones gives us quite a few different findings in autopsy. And the loss of urinary and rectal urethral sphincter tone may cause voiding of urine as feces, i.e., sorry, let me repeat, loss of muscle tone after death may result in voiding of urine and feces. And the same urinary sphincters may, i.e., the loss of a tone in the urinary sphincter may also cause leakage of semen from the penile urethra. And the last one that we did not discuss is the lower esophageal sphincter. If its tone is compromised, it will cause the regurgitation of the gastric contents, and the gastric contents will be found in the esophagus and the airways. And this is a common finding in almost all the autopsies. So let's go through this sphincter stuff one more time. Sphincter, there are three major categories of sphincters in our body. The first one is lower esophageal sphincter, the second is urinary, and the third one is a rectal sphincter, or I should say the anal sphincter. So if a lower esophageal sphincter is compromised, it will cause regurgitation of gastric contents. Urinary sphincter is compromised, it will cause voiding of urine, and it will also, another finding will be the ejaculatory stuff, i.e., semen will be found during the autopsy, and the compromisation of the anal sphincter will cause the voiding of feces. So these are some important points that you need to take home from this slide. Now, as we previously mentioned in the last slide, let's go to that. There are four major rapid changes, and we went through all of them, and now we are left with four major rapid changes. So the first major rapid change, let's go to the next slide and see a few beautiful pics. First major rapid change, you see the body is lying head down, and actually these two bodies are the same. They just position different in these two pics. In the first pic, the body is found, the dead body is found upside down, and in the next pic the body is moved, but you see the position of the hands and this flexion of the knee. This is not disturbed by moving the body, so this shows that the body has become stiff. So the first major rapid change is stiffness. But if you call it stiffness, then I don't think anyone will ever call you a medical detective. So you need to sound a little more sophisticated, right? So for this purpose, call it rigor mortis. Yes, you're right. It's rigor mortis. It's the first major rapid change that we are going to study about. What's the first thing that will come to your mind after seeing this pics is that how does this rigor mortis occur? So rigor mortis is a temperature dependent physiochemical change that occurs within muscle cells. It is a physiochemical change that occurs within muscle cells as a result of lack of oxygen. The lack of oxygen means that energy cannot be obtained through oxygen dependent energy yielding pathways. So the cell has to rely on oxygen independent pathways that will cause the production of lactic acid, and the increased level of lactic acid will cause increased acidity. So increased acidity, so the first thing that will happen is there will be decreased ATP due to lack of oxygen. The cell will shift its oxygen yielding pathways to anaerobic, and which will cause increased lactic acid level, so there will be increased acidity. In decrease ATP and increase acidity are the two factors that control the post-mortem stiffness or the rigor mortis. The mechanism is this. In the presence of low ATP and high acidity, the actin and myosin fibers bind together. And the binding of actin and myosin fibers forms a gel. And the net outcome of this formation of gel is the stiffness or the rigor mortis. So let's go to the next slide and see what we have there. Rigor mortis. In the presence of low ATP and high acidity, the actin and myosin fibers bind together and form a gel. And the outcome of this formation of gel is the muscle stiffness. And you won't call it muscle stiffness, you will need to sound a little more sophisticated, a little more modern, so you will call it rigor mortis. So let's ignore this second bullet point and go to the next one. What are the factors affecting the rigor mortis? Can you think of any factors? I have told you already. Can you guess them? Yes, low ATP and high acidity. The earlier these two conditions are met, the earlier will be the rigor mortis, and the later these two conditions are met, the later will be rigor mortis. This is the reason that the progression of rigor mortis is not uniform. Let's go to the second bullet point to understand it. Progression of rigor mortis. It normally develops uniformly, but in most of the cases it is seen to progress from smaller muscles of eyes and mouth to legs as larger and larger muscle groups become stiff. So why this pattern from smaller to larger muscles is followed is because of the factors. Like I previously mentioned, the earlier these two conditions are met, the earlier the rigor mortis will follow. And the reason these two conditions are met earlier in smaller muscles is because smaller muscles have low reserves, low levels of glycogen and glucose. So low levels of glycogen and glucose, they will quickly lose ATP, and quickly lactic acid levels will rise in their cytoplasm. So when these two conditions are met, rigor mortis will ensue. That's not all about rigor mortis. And there is some other stuff that we need to revise. Rigor mortis, what's the significance of rigor mortis? Can you guess anything? Its progression. Yes, its progression can help us calculate the PMI. What's PMI? PMI is post-mortem interval. But rigor mortis is not that इतना कोई स्टैंडर्ड का टेस्ट नहीं है पोस्ट-mortem इंटरवल के लिए. So how do you calculate the post-mortem interval? Is simply that in temperate conditions, rigor can commonly be detected in the phase between approximately 1 and 4 hours after death, and in the limbs between approximately 3 and 6 hours after death, with the strength of rigor increasing to a maximum by approximately 18 hours after death. Now these two sentences that I just spoke are enough to ensure rigor in each of you listening to me right now, I know. So the better version of this is, or rather I should say the easier version of this is row 12. What's row 12? R means rule, O means of, rule of 12. There are 3 points of this rule. Never mention it in Viva or anything, right? It's just my own invention. It's not a medical term or forensic term. Row 12 means that a rigor will ensue at about 12 hours after death. And after next 12 hours, the rigor will be at its peak, i.e. the stiffness will be most. And after again next 12 hours, the rigor will have completely ceased to exist. So after 12 hours, the rigor will start, and after more 12 hours, or we can also call it 24 hours after death, the rigor will be at its peak, and after about 36 hours, the rigor will end. Another some of the few important points about rigor are mentioned in the following bullet points. Post-mortem delivery can occur due to rigor mortis. Further ejaculation can occur due to the compression, or I should say the spasm of the ejaculatory ducts and vas deferens, etc. This can cause further ejaculation. So why did I call it further ejaculation? Why did I not call it ejaculation will occur? Can you recall? Why did I mention further? It's because of this thing. In the minor rapid change, there is loss of sphincter tone, and this causes the earlier ejaculation. And after death, and after the minor changes, when the rigor ensues, there is further ejaculation, and that's why I mentioned further in the text. So there are some important features that you need to know about the rigor. The first one is that due to rigor mortis, left ventricles get thickened and contracted. So it should not be mistaken as hypertrophied heart. Left ventricles get contracted and it should not be mistaken as hypertrophied heart. And the last point is cutis and serina. Now this sounds very like very yo-yo to me. Like, have you ever saw those Godfather Italian movies in which they use terms like consigliere, pesanovantes, corpo regime, stonzo, etc. Cutis and serina sounds just like that. So I like this term a lot. I don't know whether you are okay with it or not, but the concept is very simple. Due to rigor mortis, erector pili muscles contract, and there is puckering of skin. Puckering of skin means the skin becomes goozy in appearance. It must be mistakenly seen as skin seen after drowning. So after drowning, all the hair of the body are standing, and same is the condition. Same thing is seen with in cutis and serina, in which all the erector pili muscles contract and all the hairs are standing, which is called goozy skin appearance. And this goozy, another term for this goozy skin appearance is cutis and serina. And why do we need to call it cutis and serina? Because if you call it goosebumps or goozy skin, no one's gonna respect you as a forensic scientist or a medical detective. So that's all about the rigor mortis, and then we go to the second rapid major change. Actually, that's a very cute slide, and I don't think you need to know a lot about it. So ignoring the text, let's see this hand first. What does it tell you about? This hand shows that the person died holding this weed or this vegetation. So is it rigor mortis that the hand is still contracted? Yes or no? Yes or no? No, right? Why no? Because if it were rigor mortis, then prior to rigor mortis, we previously mentioned there is primary flaccidity, and then there is rigor mortis, and then we have secondary rigidity. So if it were rigor mortis, the vegetation would have been lost from the hand, and there will be no finding of any weed in the hand after the rigor was achieved. So this is something different. This is called cadaveric rigidity, or also known as instantaneous rigidity. It is the rigidity obtained at the instant of death. It is another term for instantaneous post-mortem onset of rigor mortis. Most cases are said to be related to deaths. Most cases are said to be related to individuals who are at high levels of emotional or physical stress immediately before death. And many historic reports relate to battlefield casualties. Individuals recovered from the rivers with weeds or twigs grasped firmly in their hands, or the finger of a suicidal shooting found tightly gripping the trigger. So the summarized or the easier version of all this is that the instantaneous rigor is found in individuals who are at high levels of physical and emotional stress at the time of the death, and it persists until the rigor mortis develops. As secondary muscular flaccidity starts, it goes away, and the importance of it lies in the knowing the conditions preceding death. Importance of the instantaneous rigor is to know the conditions preceding death. Like for example, in suicidal deaths, what will you see gripping tightly in hand? There will be a firearm, a rifle, a knife, or a pistol gripped tightly in hand. Or for example, in case of drowning, as is the picture on the left hand side of this slide, you will see vegetation or twigs or weeds firmly catched in hands. In case of homicide, there will be clothing or hair in deceased hands. There will be hair or clothing in a deceased hand in case of homicide, and in mountain casualties, the branches of trees or shrubs or even stones can be found in hands. So let's go through this slide once more. uh, it's quite easier, but still I think I need to make some things a little more clearer. Cadaveric spasm is also known as instantaneous spasm. It is a condition of muscular rigidity immediately after death without a stage of primary flaccidity, and it persists until rigor mortis develops. The next thing you need to know is that as secondary muscular flaccidity starts, it fades and it completely goes away, and it is associated with high levels of emotional or physical stress prior to death. And its importance lies in determining the conditions preceding death, like for example in suicidal death, knife, firearms, or things like self-harming stuff, like a pistol will be found gripping tightly in the hands of the cadaver. And in drowning cases, you will see grass, weeds, and vegetation gripped firmly in hands. In cases of a homicide, there will be clothing or hair in the hands of the deceased. And in mountain fatalities and mountaineering related deaths, there will be stones, branches of trees, and shrubs grasped tightly in hands.